Hello everyone. In this video, I am going to discuss most important laws, Kirchhoff's laws. These Kirchhoff's laws are very useful to analyze the electrical circuits. And before going to study the Kirchhoff's laws, it is better to know the concept of network terminology. And this network terminology is helpful to understand the Kirchhoff's laws. For that, I am considering simple electrical circuit. This is R1, R2, R3, R4. And this is some source V. V, yes. From this network, there are some basic definitions. The first definition is nothing but node. Okay, what is the node of this electrical circuit? What is the node of this electrical circuit? Simple. Node is a point or junction in an electrical circuit. Node is a point or junction in an electrical circuit where two or more circuit elements connected together. Where two or more circuit elements connected together. And the nodes are classified into two types: simple node and a principal node. Simple node and principal node. What is meant by simple node? It is a node at which two circuit elements are connected together. Remember, this is important. It is a node at which two circuit elements, at which two circuit elements are connected together. And principal node, it is a node at which more than two circuit elements. Simple node means only two circuit elements. Principal node means more than two circuit elements are connected together. Is it clear? Yeah. From the circuits, suppose I'm assuming some points. This is A, B, C, D, E, and F. Okay. And at point A, observe there are two circuit elements are connected. At point A, there are two circuit elements are connected. Then point A is called as simple node. Point A is called as simple node. And remember, note all principal nodes are said to be simple nodes, but not all simple nodes are said to be principal nodes. Remember, this is very, very important. All principal nodes are said to be simple nodes, but not all simple nodes are principal nodes. Point A is at point A, voltage source and resistor is connected, therefore it is treated as one simple node. This is S1. And point B, R1, R2, R3. Three resistors are connected at point B. This is treated as simple node as well as principal node, S2 and P1. And at point C, resistor R3 and resistor R4. Two branches, two elements are connected at point C. Therefore, this is considered as simple node 3. And observe downwards, D, E, F all are connected to same point. All are connected to same points. Down, I'm considering total as one principal node, or and it is also a simple node. Means in the given circuit there are four simple nodes and two principal nodes. Four simple nodes and two principal nodes. Okay. Simple nodes are two. S equal to, sorry, simple nodes are 4 and principal nodes are 2 from the given circuit. Is this clear? Yeah. Coming to next definition, branch. What is the branch of this electrical network? Remember, branch is nothing but any two-terminal circuit element. Any two-terminal circuit element is called as branch. Any two-terminal circuit element is called as branch. AB, BC, CD, BE, and AF are called branches of the electrical network. Therefore, or simply each individual element in a circuit is called as branch. Each individual element in a circuit is called as branch. One, two, three, four, five. Total five branches are there in a given network. B is equal to 5. Total 5 branches. Okay. Next, loop. Loop is nothing but any closed path of the circuit. Loop is nothing but any closed path of the circuit. Closed path means the starting and finishing points are same. Starting and finishing points are same. Any closed path of the circuit is called as branch. In the given circuit, A, B, E, F, yeah, this is considered as one loop. Okay, next B, C, D, E, B. This is also considered as one loop. Next A, B, C, D, E, F. Again A. This is also considered as A, B, C, D, E, F, A. This total circuit is considered as one loop. Is it clear? And there are three loops in a given circuit. Is it clear? Yeah. Next one, mesh. This is very, very important. Mesh. A mesh is the most elementary form of a loop. Most elementary form of a loop and cannot be further divided into other loops. Means mesh is also a closed path, but no other loops or no other closure paths inside it overlap. No other closure paths overlaps the inside the mesh. Is it clear? Mesh is an individual loop. Okay, now no other loops, no other closure paths inside it. Means there are two meshes in a given circuit. A, B, E, F, A, B, E, F, A, and B, C, D, E, B. Two meshes in a given circuit. Is this clear? This is the definition of mesh. And remember one note here, all meshes of an electrical circuit is considered as a loop, but all loops are not meshes. This is very, very important. All meshes are generally considering as a loop, but all loops are not meshes. Because why all loops are not meshes? Loop is nothing but inside a loop other loop also exists, inside one loop other loops are exist, it is overlapping. Mesh is nothing but individual loops. That's why all meshes are loops considered as a loop, but all loops are not meshes. These are the some basic definitions related to the electrical circuit. Yeah. Next we are going to study the different types of Kirchhoff's laws. We know that Kirchhoff laws are classified into two types: Kirchhoff's current law and Kirchhoff's voltage law. Yeah, first we are going to discuss about Kirchhoff's current law. KCL. It is related to currents at any node or junction in an electrical circuit. Remember, KCL is related to the currents. KCL is related to currents in an electrical circuit. KCL is related to currents at any junction or node. Is this clear? Yeah. And it works on the principle of conservation of energy. This is the most important thing. KCL is works on the principle of conservation of charge. KCL is works on the principle of conservation of charge. I'm going to explain this why the KCL is working on the principle of conservation of charge. Yeah, first we are going to see the statement. What is the statement of KCL? Remember, to state anything we need to understand the key point of the statement. What is the important point? What we are going to explain in that statement? Means to state the KCL, The main important thing, we are defining KCL at node or junction. We are defining or we are stating KCL at node or junction. Therefore, we need to start the statement at any node or junction in an electrical circuit. At any node or junction in an electrical circuit, the algebraic sum of all currents is equal to 0. The algebraic sum of all currents is equal to 0. Algebraic sum of all currents means I am considering incoming and outgoing currents at a junction or node. Incoming and outgoing currents at a junction or node. And to apply KCL at any particular node, I am assuming that currents towards the junction point is positive and the current away from the junction point is negative. Current away from the junction point is negative. Suppose I am considering one node here. I am considering one node here. This is my node. This is my node or junction. Okay. At this node, there are different branches are connected. Different branches are connected like this. And these are the branches connected to this node. And when the branch is connected, there is a current. I Total 5 branches are connected. The current in branch 1 is I1. The current in branch 2 is I2. The current in branch 3 is I3. The current in branch 4 is I4. The current in branch 5 is I5. Total 5 branch currents. Then by applying KCL, by applying KCL at a node, we know that the statement of KCL at any junction, at any node or junction, algebraic sum of all currents is equal to 0. Algebraic sum of all currents means incoming currents and outgoing current is equal to 0. Current towards the junction is positive, current away from the junction is negative. Based on that statement, we are writing I1 is towards the junction, means it is considered as positive I1. And next I2 is also towards the junction, it is also considered as positive plus I2. And I3 is leaving from the junction, it is considered as negative. And I4 is also leaving from the junction, it is also negative. And I5 towards the junction, it is considered as positive. Plus I5 is equal to 0. This is the KCL equation at this node. KCL equation at this node. From this equation, I am writing I1 plus I2 is equal to I3 plus I4 plus I5. Incoming currents is equal to outgoing current. Incoming current is equal to outgoing current. Generally, the definition of current. What is the definition of current? What is the definition of current? Current is the nothing but flow of electrons through a free conductor. Flow of electrons through a conducting material, or it is defined as the rate of change of charge for unit time. I is defined as the rate of change of charge for unit time. Generally, the equation of current is nothing but I equal to dq by dt. I is equal to dq by dt. The equation of current is nothing but, because current KCL is related to currents, right? KCL is related to currents. Therefore, the definition of current, it is defined as the ratio of, it is defined as the rate of change of charge for unit time. It is defined as the rate of change of charge for unit time. Here we are considering charge is nothing but units. Therefore, from this, I is directly proportional to charge. I is directly proportional to charge. Current is directly proportional to the charges. Therefore, KCL is related to currents. Therefore, KCL is works on the principle of conservation of charge. KCL is works on the principle of conservation of charge. Is this clear? Yeah. This is very, very important. KCL works on the principle of conservation of charge. This is about Kirchhoff's current law. Kirchhoff's current law, first law. Yeah. Next, Kirchhoff's second law, KVL. Okay. KVL means Kirchhoff's voltage law. KVL is related to voltages in any closed path of a circuit. Okay. Now, KVL is related to voltages of a closed voltages in any closed path of an electrical circuit. KVL is related to voltages in any closed path, in any closed path of an electrical circuit, in any closed path of an electrical circuit. Remember, KVL is related to voltages. KVL is related to voltages in any closed path of an electrical circuit, and KVL is works on the principle of conservation of energy. Remember, KVL works on the principle of conservation of energy. KVL works on the principle of conservation of energy. And the statement of KVL, same. And KVL is defined or state KVL in any closed path or mesh of an electrical circuit. In any closed path or mesh of an electrical circuit. What will happen in that closed path or mesh? The algebraic sum of all voltages is equal to 0. In any closed path or mesh, in any closed path or mesh of an electrical circuit, the algebraic sum of all voltages is equal to 0. Means all voltages means in that closed path or mesh, there may be a voltage rise and voltage drops. There may be a voltage rise and voltage drop. All these voltages must be equal to 0. And to know the when to know when in a actually, suppose we are considering one mesh or closed path and we don't know when the voltage is rising and when the voltage is dropping. When the voltage is rising and when the voltage is dropping. To explain this concept, and there is a simple concept called sign convention. Sign convention. And this sign convention helps to know the polarity of voltage based on the current direction. Is this clear? It helps to know the polarity of voltage. Polarity of voltage based on the current direction. Remember, this is very, very important. Based on the current direction. Sign convention helps to know the polarity of voltage based on the current direction. Okay. Suppose I am considering one voltage source. Same, I am considering another voltage source. This voltage source connected between 2 points A and B. This is also connected between A and B. And the polarity of this voltage source, positive and negative. And here same, the polarity of voltage source is positive, negative. Okay. Next, suppose in first case, the direction of current is from like this. Okay. Now, in the second case, the direction of current is like this. The direction of current is like this. In first case, current is flowing from positive to negative. Current is flowing from positive to negative. In second case, current is flowing from negative to positive. Current is flowing from negative to positive. Observe clearly, this is for voltage sources only. I am considering sign convention. I am considering for voltage sources. Voltage sources. And first current is flowing from positive to negative, and second is flowing from negative to positive. When the current is flowing from positive to negative, generally positive means higher polarity, negative means lower polarity. When current is changing from higher polarity to lower polarity, higher polarity to lower polarity, this is considered as voltage dropping. Higher to lower, voltage is decreasing. This is considered as voltage drop. Voltage drop. When current is changing from positive to negative, it is considering as voltage drop. And when the current is changing from negative to positive, lower potential to higher potential, it is considered as voltage rise. This is very, very important to understand Kirchhoff's voltage law. Voltage rise. Is this clear? Generally, for voltage drop, for voltage drop, I'm considering for voltage drop, I'm taking negative sign, and for voltage drop, I'm considering positive sign. Is this clear? This is the concept, and it is used it is useful to write KVL equation in any closure path. This is the most important concept, sign convention for voltage sources. Suppose if any resistor is connected in the circuit, suppose instead of voltage source, if any resistor is connected in the circuit, if any resistor is connected in the circuit, suppose this is connected between A and B, and it is R. Okay, now, and we know that resistor is a passive element. We know that resistor is a passive element, and the purpose of passive elements is to receive the energy. The purpose of passive elements is to receive the energy. Therefore, always in a resistor, voltage drop is occurring. Always in a resistor, voltage drop. Voltage drop is occur. Voltage drop is occurring. Remember, this is very, very important point. If any resistor is connected in a circuit, we writing voltage drop is occurring in a resistor. That is, we are taking negative sign. We are taking negative sign. That is, voltage drop is equal to minus R into I. Minus R into I. This is the current, and this is the voltage drop. Suppose VR. VR is equal to minus R into I. Is this clear? This is about sign convention. Yeah. Then next I'm explaining the KVL statement. For that I'm considering simple electrical circuit. Simple electrical circuit. And this is R1, R2, R3, and this is source VS. VS. And these three resistors are connected in series. These series combination connected to the source. When these three resistors are connected to the source, then source supplying current I. Then current I is flowing in a circuit. Current I is flowing in a circuit. Current I is flowing in a circuit. When current is flowing through the resistor R1, R2, R3, there is a voltage drop. There is a voltage drop. The drop we are calling generally the drop across resistor R1 we are calling V1, and it is V2, and this is V3. This is V1, V2, V3. Is it clear? Yeah. Then we are applying KVL to this simple closed path, closed loop or mesh. We are applying KVL to this closed path. Current I is flowing in this closed path. Yeah. By applying KVL, by applying KVL. We are writing resistor, three resistors means definitely in a resistor voltage drop is occurring, and for voltage drop we are considering negative sign. Therefore voltage drop across resistor R1 is V1, and voltage drop across resistor R2 is V2, and resistor R3 is V3. Therefore we are considering minus V1, minus V2, and it is minus V3 because it is a resistor. In a resistor voltage drop is occurring. And observe in this source the direction of current. Current is flowing from negative to positive. Current is flowing from negative to positive. When current is flowing from negative to positive, we are this is voltage rise. Voltage rise we are writing positive sign. Plus Vs equal to 0. This is the KVL equation of the simple circuit. Is this clear? Or Vs is equal to V1 plus V2 plus V3. Vs is equal to V1 plus V2 plus V3. Yeah. And we discussed KVL works on the principle of conservation of energy. For that, we know that equation of voltage V is equal to, what is the equation of voltage? dW by dq. Equation of voltage is nothing but it is dW by dq. What is the definition of voltage? It is the rate of change of energy for unit charge. Rate of change of energy for unit charge. Voltage is defined as the rate of change of energy for unit charge. Means here the charge is unit charge. Charge is unit 1. Therefore, V is directly proportional to, from this, V is directly proportional to dW means energy. V is directly proportional to energy. Therefore, KVL. Therefore, KVL is works on the principle of conservation of energy. KVL is works on the principle of conservation of energy. Is this clear? Yeah. This is about Kirchhoff's laws, Kirchhoff's current law, and Kirchhoff's voltage law. Thank you.